In this video, we're going to be going through a pretty difficult mechanics question. So it's told you quite a lot of information here. It's told you the mass of the pellet itself, 8.8 grams. We do have to convert that into kilograms, by the way, before we use it in calculation. It strikes a stationary block, okay, and becomes embedded in it, okay. The center of mass rises by 0.63 when the pellet becomes combined to the block. And the block has a mass of 450 grams. Determine the speed of the pellet when it strikes the wooden block. How you can go about doing this? Well, we can't use that because it hasn't given us enough variables for that. We can, however, consider the momentum. We can say that the momentum of the pellet before it strikes the block, so before, sorry, it's just taking me a little bit of time to write this out, before striking the block is equal to the momentum that both the pellet and the block move up with some of system afterwards. Now we know the initial, so momentum, by the way, it's mass times velocity. We know the mass of the pellet before it strikes the block. It's 8.8 times 10 to the minus 3. We don't, however, know the speed of the pellet before it strikes the block, and that's actually what we need to find. Let's call that variable x. That's equal to the momentum of the system as it moves up. Now the mass of the whole system is the combined mass of the pellet and the block because the pellet becomes embedded into the block. So 8.8 plus 450 is 458.8, and then so that's 458.8 grams, by the way. You then divide that by 1,000 to convert it into sorry, it's a little bit late, 0.4588 kilograms. And you multiply that by the velocity that this whole system of when the pellet is combined into the block moves up with. Now, how do you find that velocity that it moves up with? Well, that's where we actually use the conservation of energy, and that's what makes this question a lot more difficult than it looks. What we can say is that the kinetic energy that the pellet and the block gain when the pellet sort of strikes into the block, it becomes equal to the gravitational potential energy that the pellet and block then move up with, and that's why it's giving you that height. Gravitational potential energy, we know is mgh, and we know the mass of the whole system is 0.4588. You multiply that by g, and which is 9.81, and you multiply that by the height that it moves up at, 0.63, and that's equal to 2.84 joules. Okay, that means that the kinetic energy that the pellet sort of provides the block is 2.84 joules. So we can say that that kinetic energy is equal to a half mv squared. Rearranging this for velocity, we multiply both sides by 2, sorry, it's getting a little bit messy, 2 times 2.48 all over the mass, which is the combined mass of the pellet and the block, 0.4588, and that's equal to v squared. You can then square root both sides from there, and you get that the velocity that the pellet and block move off with is 3.51 meters per second. So that's the momentum that the system sort of moves off with, 3.51. Now that we've got that, we can then rearrange this equation to find x, which is the speed that the pellet initially came in with. So you divide both sides by 8.8 times 10 to the minus 3. 8.8 times 10 to the minus 3. And putting that all to your calculator, you'll actually get a speed of 1.61. It's alright. 1.61. Alright. Sorry. You get 183 meters per second. I was thinking that's a little bit too small. Okay, it tells you the wooden block is now replaced by a steel block. So it's this block here that's replaced by a steel block. The experiment is repeated with the steel block and an identical pellet, but the pellet rebounds. That's very important. Discuss how the height of the steel block, the height that the steel block reaches is varied. And you have to talk about the energy changes and momentum changes. Well, let's think about it like this. If the pellet comes in with 183 meters per second into this wooden block, and then after it combines with this wooden block, it moves off with 3.51 meters per second. What do we know the change in velocity is? Well, it's the change between 183 and 3.51. That's 179.49 meters per second. If, however, the pellet comes in with 183, but then it rebounds, let's say with a speed of, I don't know, but here's the thing, the velocity is going to be negative wherever it is. Let's say it's minus 10. The change in velocity is going to be 183 plus that extra change, because it's gone from positive to negative. So what we see is that, and the first note that you want to make is that with the steel block, there's a larger change in velocity. Now what does that affect? Well, that means that there's a larger change in momentum, or you can say rate of change of momentum. If there's a larger change in momentum, that means that the momentum of the pellet before it strikes the block is larger. So the momentum of the whole system that it moves up with is larger. So system moves up with more momentum. Breaking down momentum is mass times velocity. If the momentum is larger, the mass of the whole system is constant. So it's the velocity of the system that's larger. So that means that the block moves off initially with more velocity. So the block has, or we can say gains, more velocity. That's important because what energy relates to velocity? Kinetic energy. So we say that the block gains more kinetic energy as a result. Now what is that kinetic energy turning into? It's turning into gravitational potential energy. So we say that the block gains more gravitational potential energy. And then gravitational potential energy is mgh. M is constant, g is constant. So if there's a larger gravitational potential energy, that leads to a larger height being reached. Hopefully you get to see how all this sort of links together. But again, a very difficult question. Yeah, that's everything for this question. If you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video if it helped, and yeah, subscribe.